So what are some factors that we need to consider when we're talking about the transformation of going from f of x to square root f of x? Or in other words, what is the transformation when we square root a function? So there's two things going on. First of all, we are going to get rid of negative values. So we get rid of the negative f of x. Okay, so that when the output is negative, we can't use that in the input for the square root. Okay, secondly, we bend down the positive parts of the graph. Okay, so there is a part of the graph that actually bends up, and that's the part that when we square root, it's going to be the decimal values. So from 0 to 1, if we actually square root numbers from 0 to 1, they actually get bigger. So that's why we have this little bump here. So if you're wondering why I drew that little bump, that's the reason why. But in general, I want you guys to understand these two concepts. We get rid of the negative, and you're going to bend down the positive parts of the graph. Okay, so that's the idea behind square root as a transformation. Now we can also look at this square root transformation as an embedded function. Okay, so we have an outside function, which is our square root, and the inside function is our f of x. And this becomes this composition of functions or embedded functions. And how it works is that what we have is our input. Our input goes into the first embedded function, the inside function, the f of x, and then we get an output, and that output then becomes the input for the outside function. In this case, it's g. For our purposes that we've been working with, the output, the outside function was the square root. So for our square root examples, our output f of x we can only use the positive versions of this output to be able to go into the input. Okay, so we end up having to have our input is then restricted based on what we can output here and what we can put in through here. Okay, so it's like a traffic jam here. There's like a filter that filters out we can't use everything that comes out of here because some of it, okay, is not able to go through the square root or the outside function. Okay, so this is the idea. This idea comes in becomes more important later on when we start dealing with the composite functions. But this idea of an inside function that we have to apply first, the output of the inside function then is applied as the domain or the input of the outside function. And that domain can restrict what's coming through this whole function flowchart.